Good afternoon. Welcome to this new webinar organized by Edu for Standards. I have a few slides that I will share in a second. While we wait for all the registered people to connect. You should see properly the screen now. So welcome again. My name is Maria Giuffrida. I'm from Trust IT, and together with my colleague Sabrina, we are leading the communication activities of Edu for Standards. And now we are in a specific set of webinars, let's say a group of modules focused on the green and digital transition. So we've started to organize this in the last year of the project. And for those of you who have not participated in past events or are not very familiar with Edu4 standards, we have this one nutshell slide to tell you a few things about the project. So this is an EU-funded initiative started in January 2024. We are in the last year of three. And the main objective for this project is to basically have the standardization processes and the education system meet. And so we want to increase the number of higher education institutions offering teaching materials and courses on standardization all over Europe. We want to contribute to this scope by disseminating our frameworks, our knowledge, and the material that has been produced. And we want to engage with the community via a set of initiatives, which include events like the one of today, and more institutional and formal events like the Academic Standard Days that are organized with national standard bodies and universities. And then at the end, we will also set up a standardization students association, as well as we are in the process of developing and send workshop agreement. So you see in this slide many numbers. I won't go into the details of it, but just be aware that we have prepared over the years an innovative teaching concept for standardization, which is at the basis of all the materials and the tools that have been developed. This concept has been tested in pilots at various levels, both university and industry. And then all of this is being disseminated, as I was saying, via our channels, our reporting, and our synergies with other projects towards a set of different type of stakeholder groups. So as part of the activities and the effort of this project, we have introduced this new series of thematic modules. It's the preparation is still ongoing, and actually we welcome any one of you who would like also to contribute with their own knowledge to this series. We've had an opening module on standards as enablers of digital and green transition, a multi-level perspective on the 28th of April. And today we have the second module hosted by our colleagues at Polytechnic University of Madrid, which will be on privacy, data protection, and standards, engineering European values. And then we have another 4 modules already available on the website. For those that have a webinar, an attached webinar, you will also find the possibility to register yourself, but more of them are there to be confirmed. And so this series will run until almost the end of the project, so until October 2026. Just a few notes on the housekeeping. So the event is being recorded. The recordings and the slides which will be presented will be made available on our website within next week. We will have a dedicated slot at the end of the webinar to address any of your questions, but just to facilitate our job in collecting these questions, you can enter them anytime in the comment box, so in the chat, sorry, and in the Q&A box, which is placed in the lower toolbar that you should see on Zoom. You can use the chat also to share any links that is connected to what is being presented or any relevant resource for the topic being discussed, and we will use the chat as well to give you some important links. So these are a few links that we will put now in the chat to be subscribed to our newsletter and to download our material, such as the flyer. And with this, I stop sharing my introductory slide and I leave the floor to the speakers of this webinar. So to Ugo from UPB first, and then Yod. So Ugo, the floor is yours. Thank you.
Thanks, Sabrina, Maria. Please let me now to share my screen. It's okay now?
Yes.
Okay. Thanks, Maria, thanks, Sabrina, also, thanks, Edu for Standard Project to allow us this opportunity to present this webinar as part of our contribution from UPN. Today, we will discuss how standards are not only about technical interoperability, but also how about shaping key properties of digital systems such as privacy, data protection, and trust. The session try to connect standardization with European Union regulations such as the GDPR engineering practice and the emerging challenge of generative artificial intelligence. This session will be mainly conducted or presented by José Samuel Martín García. He is assistant professor at the Universidad Politécnica de Madrid. His teaching and research focus on software systems and service engineering, with particular emphasis on cybersecurity, requirements, privacy engineering, identity management, and the responsible use of generative artificial intelligence in education and engineering practice. He has contributed with several European projects. And also I would like to remark about the José Samuel has received the Emilio Asset Research Award from the Spanish Data Protection Agency for his contribution to privacy and data protection engineering. Jot, many thanks. We appreciate your work and your time for this webinar, and many thanks again for being with us this afternoon. Let me to give the floors. The floor is yours.
Thank you, Hugo. Thank you, Maria. Thanks for the invitation. Thanks also for addressing this important topic, which is standardization, but not just standardization, but also its application to an area which is not as known as others, which is related to the digital rights, the European values, and the human rights applications to the digital arena. And in particular, what we are addressing today, which is the relation of privacy and data protection with standardization. In fact, privacy and data protection are an excuse today, because what I would like to provide is a general overview of standardization addressed to non-technical people, to non-savvy people in the area of standardization. Being myself someone who has worked on several standardization committees, but not directly linked so tightly to standardization as someone who might be working on standards development organization, standardization body. Sometimes I find that it's difficult to understand what standard is, what they are used for, what they are useful for. And that shallow introduction to that might be of quite value to novices in the area. So I would like to, as the script for this webinar already indicated, I would like to provide that introduction to standardization, what I've called the 5 Ws of standards, And then, yes, I will talk a bit about how this world of standardization is related to privacy, and in particular, in the end, some of the challenges that generative AI, which is everywhere nowadays, it's also in privacy standards, some of the challenges that are being addressed there. So without any further ado, let's start with the 5 Ws of standardization. Maybe you have heard that expression, 5 Ws. This is quite typical in journalism to answer 5 questions. The traditional journalism schools say that any good article must answer these questions at the beginning: who, what, when. I don't have the when here, I have which, why, and how. So I think this is a great framework to address the answers, this shallow introduction to standards. And this is what we're going to do during the bunch of today's webinar, to answer what a standard is, how are standards created, but also how they are accessed, who creates those standards, why we would like to gain access to standards or to participate in the standardization process, and what standards exist out there. Well, not all of them, not even part of them, just a sample, so that we can get the idea of the role of standardization, in particular in the area of telecommunications and information technologies. So what is standard? Well, this is not the formal definition of standard, but a practical one. A standard is an agreement that provides hints for good quality, wherever good is considered in the area, and which defines what is normal. So we are going to go into depth. We are going to delve into all those things with examples. An agreement means that standards could be different. Standards, the contents of standards are arbitrary but reasonable. For instance, I have there on the right-hand side an open mouth that is somehow pronouncing an sound. And there I have the alphabet there. We can say this is the ABCs of standards, literally. So the alphabet is great. The writing system and the alphabet ordering is a great example of standard. More or less, alphabetic systems reflect the pronunciation of different phonemes. So it is considered in spoken language as the minimal unit. And they try to reflect with more or less success a correspondence between phonemes and symbols, glyphs, which we call letters, in, as I said, alphabetic systems. There are other writing systems. So it's reasonable to have that correspondence between one sound and one phoneme, or between a few sounds, one letter and one phoneme, or a few letters and a few phonemes. It's not one-to-one, the correspondence. But what specific correspondence it happens? This is arbitrary. So, for instance, in Spanish and in other Romance languages, when we put that open mouth saying a, we represent that with the A letter and with the uppercase or lowercase, which are indeed quite different. So there's no reason why it should be like this or like this. But in other languages, as in Hebrew, this is the glyph that represents the alif letter, the glyph that represents the A sound. So we see here that there's a correspondence. It's reasonable, but it's arbitrary. It could have been different. Also, it makes sense to sort the letters in some order so that we can have the agendas, the phone books, and dictionaries, etc. But which order? This is something that can be different. So for instance, here again, we have that the letter in the Hebrew alphabet that has the third position is equivalent more or less to English or Latin G, not C. But there's an order. So there's an agreement that everybody is going to follow the same order and that everybody is going to write with specific orthographic rules for each language. Indeed, there are different standards. Yeah, there are different writing standards. But it's arbitrary. It could have been different. This is also something that we finding other standards. So, for instance, plugs and sockets, electrical plugs and sockets. We need to create an electrical contact, but it could have been different. In fact, it's different in different countries. It could have been flat, the plug might have been flat, or it could have been round, or there isn't any physical law that tells that it should be that way and not the other way around. Or the thread of screw and the bolt, the distance between each turn, the direction that it turns, which is clockwise. This is something that everybody needs to agree on to make it interoperable, which brings me to the third point. We consider standards not just agreements, but agreements that we consider normal. In fact, in many languages, standardization uses the root normal. In Spanish, we say normalización. In French, it's the same, because they are norms. But they are norms not in the legal sense, but in the technical sense. We'll see later what that means. And thanks to that normalization, we achieve common interoperability. We have plugs that we can plug into sockets. We have screws that we can put into nuts and bolts. And we have writing systems that we can use to communicate with one another. I put there alphabets, electrical plugs, and hardware. But we may wonder, can human rights also be subject to standardization? Well, not directly. Human rights is a different animal. But as we will see, privacy and data protection, which are rights, established and recorded as such by the declarations of human rights, are related to standardization. So let's go to another W, the who. Who creates those standards? Well, standards are created not by individuals. I may come up with a great solution for something, but it's not standard. It will not be a standard unless and until it's not part of an agreement that is reflected by standardization development organizations, SDOs. And we have two large groups of SDOs, de jure and de facto. These are Latin phrases which mean after the law and after the fact. So there are international standardization organizations, such as those that I've depicted here. We have ISO, which is not International Standardization Organization, but International Organization for Standardization. ISO is just a Greek prefix that means equal. We have also in our area of telecommunications engineering and in general communications and information technologies, the International Telecommunications Union, International Technical Committee, CEN in Europe. We also have CENELEC in Europe, ETSI, Electronic Telecommunications Standardization Institute. We also have, here I've depicted this one separately because there are many standards that are created jointly by the ISO and IEC, which are created through a joint committee. We will see that standardization organizations may have liaison agreements with other bodies, but this one is especially important. Usually, individuals or organizations do not create standards directly, and they do not participate directly in these international organizations, but they do that through national standardization bodies, those NSBs here. For instance, in Spain, we have UNE. In France, there's AFNOR. In Germany, there's DIN. In the United States, it's ANSI, but it's different from other standardization bodies. So in strict sense, it's ANSI, the national standardization body from the US. But it's not, it doesn't have the role as it has in other countries. They don't develop the standard themselves. They somehow put stamp on standards created by different private organizations. And there's a strong involvement from NIST, which is a government agency, in determining what standard is and what isn't. So it's a different way of working. So NIST products are really relevant throughout the world. And that's why I put that here, because they are referenced as de facto standards or the Euro standards when they are standards after the law. I would like to emphasize that when I say that they are after the law, this is because they are the bodies that are recognized by the governments as the standardization bodies, but it doesn't mean that the contents of the standards that they generate is legally compulsory. We'll see that just in a bit. And then there are de facto standards created by many organizations, which are associations of neutral associations of different industry members, where companies go and create standards, create documents that define how plugs should work, or how, for instance, I put there some of the most relevant in our area. We have W3C, which standardizes a lot of web technologies. It was in W3C that the language that defines how web pages are created, which is HTML, was standardized for many years. The language that defines the styles, the cascading style sheets, CSS. We also have ECMA. They create lots of standards, but those who are familiar with JavaScript as a programming language maybe don't know that this is standardized by ECMA. Programming languages are indeed standardized. We'll see that later also. OASIS is open. EDM, which is now the owner of another association, which was OMG, Object Management Group, which defines modeling languages such as UML. 3GPP defines lots of standards for mobile phones and mobile networks. 3G started because they were focused on 3G. Now we are in 5G and they are still working. So it was originally a 3G partnership project, but they are still working on that. IETF, a task force of engineers that defines standards for the internet, known as RFCs, requests for comments, but they are not requests for comments. They are de facto standards. The IEEE, which is also an association of engineers, it's the largest association of electrical engineers in the world. They have many societies, and one is societies and associations, and one is the Standards Association, which also develops standards. So you shouldn't think that this is a straight division between standards created in one place or another. In fact, there are lots of liaisons. There are lots of standards that are created in common altogether by different organizations. There are standards that are created by de facto standardization bodies, and they migrate here. So, for instance, I said HTML, CSS, JavaScript, other languages, programming languages, C, C++, they are now ISO standards. So it's not something that makes standards being one area or another forever, but this answers the question of who creates standards. And here I've put this icon, which tries to represent the harmony of a concept which is called Ubuntu in some African languages. I think it's Swahili, which is a common communal identity. Well, in fact, this is somehow similar to a Linux distribution called Ubuntu. But standardization development process is not that harmonious. There are interests, there are competition to impose some visions, and sometimes this is more civilized, sometimes it's not that much, as it happens in any human activity. But in any case, if we want standard to become standard, we need to have that agreement. So in the end, if the standard becomes standard, there needs to be an agreement. Even if the discussion has not been that harmonious, there needs to be an agreement between parties involved in the development of the standard. Okay, so next question, how? How we can read and how we can write standards? Well, there are different ways to gain access. I said read, but I mean, there are different ways to gain access to standards, depending on the body that has created that standard. It may be the case that they can be read for free, they are available on the internet, and you can gain access to them. For instance, W3C provides their standards in an open fashion. Open, I mean open access. You can read them for free. Same happens with TECMA, with 3GPP. But in other cases, you need to purchase the standard, as you would do with any book, or subscribe to a repository. You can subscribe to a repository that provides you with access to a collection of standards that deal with a specific topic, specific area, or that have been produced by a committee, part of a standard development body, etc. I know that sometimes this might be expensive, and sometimes it might not be economically, it might not provide an economic return to those that are dealing with that standard, especially if you're a student, you're a researcher, you want to get familiar with the standard, but it's not that you want to create a product that is compliant with that standard where you have a direct value that you're going to get from it. So some suggestions here on ways to gain access in a cheaper fashion, which is 100% legal. Of course, there are ways to access any human work, any work of intellect, without abiding by licenses and copyright and so on. But this is not what I want to say. What I want to emphasize is that there are ways to gain access without incurring in maybe the costs that imply the direct purchase or subscription. First, library subscriptions. You may have access to a library which has subscribed to those standards. Maybe the license is limited, maybe there are limitations of use or application or time frame, but they are there, and you might contact your library and see if they are subscribed to one of those standard databases. There are also public drafts. They don't have the binding value that the final standard has, but sometimes there are drafts that are released for free for the public to get, for instance, comments from the public. And even if some of the contents do not make it to the final standard, sometimes they are quite similar to the final standard, and in fact, they are released with that aim. And you can't claim compliance with the standard because you comply with that draft. But if your goal, again, is not claiming compliance, but reading, studying it, that's the way to know about the standard. Sometimes there are even open releases. Some of the standards about privacy that I'm mentioning later have an open version produced by the same standardization body at a different URL, and which you can use yourself. Sometimes there are dual publishers. There are standards by ISO, which are also published by IEEE and by 3GPP, or as I said, there are de facto standards that then become the Euro standards. And one of those bodies provides that for free. So for instance, maybe the ISO is charging for access to the standard, but 3GPP isn't charging for access to the standard. And it's exactly the same standard produced by both bodies at the same. Then maybe you don't have access to the standard through any of those ways, but you have access to a translation by a national standardization body. So for instance, there's in Spain, there are standards that are legally mandated. We will go to that later, as I said. And in order to be legally mandated, they must be published in Spanish. Otherwise, legal compliance cannot be required by law. So this means that the Spanish National Standardization Body unit has to translate that into Spanish. There are other standards that they translate just because they consider, or the people involved in those committees consider that it would be appropriate to have a translation in Spanish to increase their adoption, not because it's legally mandated by anyone, but it happens quite a lot. So if you live in any of those countries that have translations, you can gain access to them, or if you understand the language, you can also gain access to them, maybe at a cheaper price. There are also transpositions which do not translate, just provide a copy of the standard, but with a different header, a different numbering, and it's included in the set of national standards. And it's the original version in English without any translation, produced also by national standardization bodies. And also national standardization bodies sometimes are resellers of standards. And exactly the same document that you may get at one place at one price, you can get it at another place. So for instance, in the Swiss, the Estonian standardization body, and you may purchase a copy there. And the price may be different. It may be even more expensive, but it may also be cheaper. Okay, so this is the message on how to read. Just one additional message here, which might be important. Some standards are easier to read than others. So if you find it difficult to read, I would advise you to read a book about the standard if the standard is mature enough so that the book has been published, to get familiar with it before trying to delve into all the intricacies of the standard. As I said, some are easier to read, some are more complex because of the topic. Sometimes it's too abstract, others it's too technical. And you might see that there are books that deal with the context of the standard without providing the text itself, which would be something that wouldn't be legal, but you can get familiar with what it means, what are the implications, etc. I don't have any book to sell about that, by the way. And then how standards are written. Well, as I said, they are written by different organizations. In Europe, they are written by the European standardization organizations that I mentioned before and the national standardization bodies. They are organized into technical committees and working groups, and sometimes subgroups, which deal with specific areas of standardization. So, for instance, there are groups that deal with privacy and data protection, and they create standards on that topic. And usually individuals participate through national standardization bodies, but it may also be the case that they participate through liaisons with outside organizations, which is a practical way to participate sometimes. These are binding contributions, others they just participate to give their opinion, but this is a practical way to participate if you're involved in any of those standardizations. Sometimes industry associations, non-profits, even research projects can sign liaisons with standardization bodies, with specific committees of standardization bodies. Okay, next W, the why. So again, we have why would we read and why would we write standard? Well, you might be interested, when I say you, I mean, not necessarily as a student, but as a professional, you may want to learn the state of practice. So standard doesn't provide the ultimate breakthrough that has happened in a lab in middle of the desert in your favorite country. But what is, as I said before, agreed as common practice. So if you want to learn it, this is a nice way to do that. This is a nice place to go. If you want not just to passively receive that, but also to create something that is aligned with state of practice, if you want to create a plug that plugs into the socket, this is a much recommendable way to do that. Maybe you don't want just to create something that's compatible, but to have stamp rubber that it is compatible by a certification body. We haven't talked about certifications today. This is another whole topic, but certifications certify against standards. So certification that this complies with this product, this service, this environment, this context complies with that standard. So this is also a reason to read standards, to make your product compliant so that it gets certified. And we'll answer in the next slide whether this also allows or helps complying with law. There are other reasons to write standards. This is a bit more difficult. I mean, there are not that many people writing standards as they are reading standards. One possible reason is commoditization. Commoditization means that there are parts of your products and services that do not provide much added value. They are a commodity that anyone could manufacture, and you want to get rid of the exclusivity in your process to focus on what provides most value, most added value. So if all the industry considers the same, that becomes a commodity, and that's a reason to create standard on that area. Another reason is interoperability. Again, plugs and sockets. Web pages. Web pages are delivered by servers. They are hosted there because someone has created them with authoring tools. And then they are rendered on our personal devices through user agents, through browsers, through mobile applications, on our laptops, on our mobile phones, through voice, through text-to-speech software, screen readers for blind people, for instance. And there needs to be an interoperability between one piece and another. So they need to speak the same language. They need to have the web pages programmed, let's say, or written using the same language, HTML, the language that is created to define web pages. Or, as I said before, commoditization. Well, I forgot something really relevant. For instance, common requirements that all the products must satisfy. Well, different products have different requirements, yeah, for sure. But it's not the same if I'm programming an application for 3-on-3 basket matches with my friends, with my mates, or I'm writing the software for an ATM, an automated teller machine that is going to give money from my card or my account. But if we're talking about security requirements, privacy requirements, all the systems respond to a common set of requirements. And we want all the products, all the industry to be secure and to be compliant with privacy and data protection principles. This is that's a reason for commoditization. There are indeed standards that provide a baseline of privacy and security requirements, and also ways to address that. And it's not because we want two products to speak the security language, but because we want all the products to stick to that baseline. Another reason is cross-selling. Cross-selling means that you put something in the standard, you have additional expertise on, so the standard is there so that anyone can implement it, anyone can use it, can read it if they have purchased it, but you have deep knowledge on that area and you want it to be standard, because then everyone is going to resort to you. Anyone else can do that? Yeah, for sure. But you have the expertise that makes it easier, cheaper, or just with better quality, and you want it to become standard. Another reason is policy. Policy at small and large. There are, of course, corporate interests, there are government interests that push for the inclusion into standards of whatever is considered. There have been historical wars in the metaphorical sense on privacy aspects that might or might not be introduced in standards. And sometimes this makes standards succeed, and sometimes this makes standards fail, because even if they make it to the standard, there isn't an agreement on what is going to be part of that standard, a real agreement, I mean, because it has been imposed just by one party. I'm going to use an extra slide for this why part to talk about the question mark that I left, the open question that I left on legal compliance. So when we say standards, I said in the beginning that we're talking about norms, but they are norms in the technical sense. They are norms in the sense of what is considered normal. What I've put here, this bell-shaped curve, is known as the normal distribution. And this is the idea of normality that technical standards try to convey. This is the usual practice. It's great to be in the usual practice and not to be an outsider, because, as I said, everybody speaks the same language, everybody writes with the same spelling rules, etc. But nobody tells you that you must be, nobody tells you that you must be here. Compliance with that norm is voluntary. This is something that is done because you consider that there are benefits. There are otherwise there. This is not the same as the legal compulsory norms that are enforced by the authorities and by the states. There's a different meaning of what we call norm here, but there's a relation between one another. In fact, this is where I reflect here to the right-hand side. Complying with standards may entail legal compliance through different instruments. I'm talking here about European legislation instruments, which in summary are ways that standards provide to allege compliance with legal regulations, with legal norms. So for instance, a norm might say, and if you comply with the standard, you are complying with the law. Then the standard becomes a way to do that. Not because the standard is itself compulsory, but because it's a way to comply with the regulation. Or it may be imposed directly by the legal regulation. But the standard is just a document that exists before, conceptually. It may be developed later, before the legal regulation. In fact, the regulation sometimes mandates to standardization organizations to create the standard. And sometimes they mandate European agencies to contribute to the standards that are being created. Okay, there are different legal approaches to address the legal compliance through standards, but my message is standards are voluntary norms, but standards can be a way to support compliance with legal regulations. If you comply with the standard, then you comply with the law. Maybe there are other ways to do that, okay? Demonstrate that. But if you are able to demonstrate that you comply with the standard, you are complying with the law. This is a technique to achieve compliance with the law in a specific area. And the next point is which standard is standardized? Everything. Here I've just depicted a few areas in information and communication technologies that are subject to standardization. Communication protocols, HTTP, the protocol, the language that clients and servers in the web speak. Transport, TCP, and network protocols through IP, the famous IP internet addresses. This address has a way, the messages that route the chunks of information that go from one computer to another is the internet protocol that goes below all the infrastructure on the internet, and other routing protocols that are created to route those those packages. Modeling languages, databases, data models, they use modeling languages. SQL, UML, those are modeling languages and they are subject to standardization. Programming languages, XML, well, XML is not exactly programming language. Someone might contend that, but C, C++, Java, they are standards. They respond to specific rules that allow you to write a program in that language and run it anywhere in any platform that is compliant with that. Encryption algorithms, codecs, data formats, how integer numbers, how images, how videos are converted into bits and bytes, authentication mechanisms, and even things that are a bit more abstract, such as service management methods or extra functional guidance. What's extra functional? Well, security and privacy, as I said before. Ways to comply with those requirements, cross-cutting categories. Okay, so after this longest first part, I'm going to provide some hints on the role of standardization with respect to privacy engineering. This can be summarized in this slide, and then I will go through a list that I'm putting here just to share with you, and so that you can have also an idea of the areas where standardization is relevant in privacy. What happens with privacy and engineering? Well, first of all, I must say, privacy is relevant to engineers. It's not a thing of lawyers or managers, or not just of lawyers and managers. Why? Because if the products, if the services that deal with personal data are going to respect privacy principles and requirements, they need to be implemented. Those principles and requirements need to be implemented by the engineers that are developing and operating those systems. So, having that said, having engineers be concerned about privacy, what we find is this. What engineers find when they go out there for guidance on privacy, what they find is the thick, big book of the law, the GDPR, the General Data Protection Regulation, and other privacy laws in different countries and specialized from different areas. Now we have the AI Act, which also includes some things that are related to privacy. We have the Privacy Directive. There are many laws and regulations on that, but let's talk about GDPR. Okay, this doesn't speak engineerish. Then there are some sets of nice principles, privacy by design principles. You must provide a win-win result where privacy isn't added after the thought. This sounds great, and this is great, but this is not operational. These are just principles that must be followed, but which do not answer the question on how to do that. Then there are privacy-enhancing technologies, PETs, encryption, fully homomorphic encryption, for instance, federated learning, where machine learning is distributed among many nodes so that information is not revealed between one another. Those are great again, but they require, using them or implementing them requires a lot of savvy in the area. These are done by experts, not by engineers that are experts in privacy, not engineers that are experts in the domain of their application. And then there are lots of tools that managers use to manage the privacy in their organizations. But this is not what engineers want. What engineers want is what we have here. They want to get database models. They want to get system models. They want to get source code. They want to get issues on their GitHub, on their Jira, on the tools they use for addressing requirements. They want to talk about requirements. They want to talk about risks. What they need is this. They need engineering tools. This is not craftsmanship. This is engineering. They must be systematic. They must be cost effective. This is not something that engineers come up with just once, but something that engineers can reuse systematically and efficiently in terms of time and cost. They don't need to take a course on privacy to use those tools and introduce privacy there. They need to have privacy and data protection operationalized. Operationalizing means bringing the principles to something concrete, operational, that they can assess against, that they can measure, even if it can be done quantitatively, but even if it's not quantitative. And they need to shift the use of privacy throughout the development left and throughout the development life cycle. Left meaning since the onset of the project, since the beginning of the development life cycle, not just as an afterthought or not just reacting when a privacy breach happens. And it's for that reason that standardization bodies have been developing privacy standards for quite a long time. So, as I said, just as a summary, I'm going to provide these tables in this slide and the next. There are privacy standards that address the foundations, which are not directly related to privacy, but which are related to security, and which then can be applied to privacy. So, for instance, there's a standard here that provides a baseline for security. So, measures that can be used to address security concerns. That's what a control is. Common criteria to assess security of systems. And then we have their applications to privacy. So we have common criteria for privacy. We have here the core privacy concepts and principles that somehow translate these security principles to privacy. The privacy architecture that includes or that develops this privacy framework. Operationalization of privacy principles in the standard that is known as POM. The privacy model privacy management reference model regarding the operations and privacy. So just one thing, I'm talking about privacy as if it was part of security. This is just because these standards do that. There's discussion in the community about whether security and privacy are different animals or privacy is part of security. Sometimes they are addressed as security and privacy. I'm not leaning towards any side, one side or the other, just reflecting the fact that privacy is usually subsumed as part of security concerns. Okay, so others regarding the life cycle. So how the engineering process can introduce privacy throughout the software development life cycle. I strongly recommend this one, 27550. This is, I'm not sure if it has that number eventually, 27551-564. Okay, anyway, the one that used to have these two, 550 564, those that used to have those numbers, because they reflect quite a lot of best practice. If you are into privacy and you have heard about LinkedIn by Kim Woods and others, or privacy strategies by Jaap Hopman and other techniques to address privacy in the development lifecycle, those are included there. Also, using privacy in models, as I said, in system models, in UML, in SysML, in SQL. The process of privacy engineering, this one is also great. They have addressed this one, I mean, sorry, my mouse here. They have addressed privacy by design from a consumer protection perspective. So it's about consumer privacy, but it's not that it's only addressing consumer-facing technologies, whatever that might mean, but that they have addressed that from the perspective of consumer protection. With Michelle Shiva from the University of, I think it's Ontario. They have changed the name recently. Use cases on privacy by design. Then if we are talking about privacy, we are talking about risks that things might go wrong. Not everything in privacy is a risk. For instance, if you have a privacy policy that is easy to access and easy to understand by your users, this is something that you must do, and you can't say that there's a risk that they don't do properly. This is a requirement that your product must have. But there are lots of privacy aspects that must be addressed from a risk perspective, where there's uncertainty that something might go wrong. So there are standards as addressing that. There's some privacy impact assessment. If you're into privacy, you might have heard about privacy and data protection impact assessment. So there's a standard for that. Controls for personal identifiable information. Personal data is the term we usually use in Europe. One of the principles of privacy, one of the tenets of privacy is the data minimization. The least personal data there is, the less risk there is for that personal data. So there are standards that address different minimization approaches. Deletion, don't retain the data for too long. De-identification, make that data non-personal. You might have records of patient temperature, but it's not linked and not linkable at any way with those patients, because you want them for research. Of course, if it's part of the electronic history, it must be linked to the patient. The identification framework, zero knowledge proof privacy, how someone can prove their identity or they can prove personal attributes without proving anything else. This is also related, for instance, to age verification technologies, for which there are also standards under work. Transparency, notices, consent, privacy preferences, do not track, which is also a standard addressing privacy preferences. There are also standards addressing specific technologies, the cloud, artificial intelligence, age assurance, I just mentioned it, smart cities, fintech, Internet of Things. Yeah, there are standards that are addressing verticals. Standards that provide taxonomies, ontologies, organizations of concepts about privacy. Yeah, we have them. I would recommend you this wiki, which is maintained by one of the individuals that are most knowledgeable on privacy and data protection standards, which is Antonio Kuhn. This is part of an initiative by the European Data Protection Supervisor, which is IPEN, which is a network of professionals working on privacy on the internet. And this document contains updated information about lots of privacy standards. Well, last and shortest part of my presentation. There's AI everywhere, generative AI everywhere, so I couldn't but also include generative AI in my presentation. These two slides just provide some hint for reflection on where privacy might be relevant in generative AI. Well, the short answer is that there are lots of processes in generative AI, and all those processes deal with personal information, and this means that there are privacy issues associated there. First, when I'm not sure how familiar you are with working of an LLM. LLMs are large language models, that tools that we use for generative AI, such as ChatGPT, Copilot, Claude, etc. They have amassed a huge database, a huge base or repository of knowledge from public data sources. Those public data sources contain personal data. So this means that when they collect personal data to create that huge source, they are dealing with personal data. There are privacy issues involved there. In fact, they may infer traits about those individuals which do not appear just on that data that is there. So there's another privacy issue, not just the collection, but also the inference, the derived data. Then when it's used, the users might be providing personal data. They are usually logged into the system. So it means that their interactions can be traced, even if they don't include personal data in the messages that they are writing. So 2 issues we have here. I should have put 2 exclamation marks instead rather than 1. Then this is processed. And then as the model had personal data, when it generates a response, it's also dealing with personal data. It might even be hallucinating about individuals. So it might be providing data that is incorrect or that is not factual. And well, in the end, this propagates here. But now LLMs are not that simple. There are different architectures. I have just put one here, which is called MCP Model Context Protocol, which adds even more issues about personal data. So this means that there are external tools that are also being queried through this model context protocol, which may involve flows of personal data to and from the LLM. So, for instance, it might be the case that these tools include personal data here that is being included as part of the query. Well, this is, I'm saying the query because the query is in this case, is assembled from different parts, not only the user prompt, but also parts that come through this MCP. We can say that this is something that is intended because if the server exposes these contents through this protocol, this is something that is part of the function. Okay, maybe. But maybe the information that the user wanted to disclose to the LLM, they weren't aware that it was also going to be disclosed to this server through MCP. Or maybe the other way around, this MCP is exposing that to answer user queries, but this is also being handled by the LLM, and we don't know what they are doing there with that information. So in summary, well, this is really complex. And as this is really complex, there's a standard under development on privacy protection on artificial intelligence, which is the point that I wanted to reach to say, okay, there are lots of works on standards on privacy, but there's still work to do because as technology progresses, there needs to have work done on the area to eventually make products and services compliant with privacy principles, regardless of what the law says in different countries, comply with privacy principles and privacy requirements, so that in the end, the human rights to privacy, to private life, to privacy and protection of personal data are embedded into products. So that's everything from my side today. I think that we are almost in the expected time. Here you are the contacts of the project and myself. And I would stop sharing for a while so that we can answer any questions that the moderators have gathered or that you are sharing now. Thank you.
Thank you. Thank you very much, Yod, for your presentation. While you were speaking, we have received some points in the Q&A. Like one is both from Cyril. So thank you, Cyril, for your contributions. One is actually a comment. I don't know if you can read it or I read it myself. Cyril says it's a pity to say that standards might be difficult to read without offering help. Couldn't NSB offer helplines? NSBs should take action and review standards difficult to understand. So it's a comment. I don't know if you want to reply to this, but then after we have a question regarding if there is any of the standards for privacy accessible to be read without paying charges.
Yeah, so I'll start from the second question. Yes, there are standards that can be read without paying charges. For instance, those by W3C that I mentioned are accessible for free. Then let me revise. I think it was 29100, the one that is accessible for free. ISO 29100, ISO IC 29100. And those are two that just first come to my mind. But yeah, some of them can be accessed for free. Oasis Pinrim is also accessible for free. And as I said, there are different mechanisms to get cheaper access to them. Then regarding the other question, yeah, sometimes standards are difficult to read. This is the result of, I said that compliance with standards is voluntary, but also contribution to standards is voluntary. I mean, the people that are working on standardization bodies, well, the people that work for standardization bodies, for the organization and management, for sure, are getting a salary, but the people that are contributing to standards don't directly get paid for the contribution. They are paid by their company that wants to contribute to standards. And that means that they do their best, and sometimes they achieve results that are more readable, and sometimes they are more difficult to read. It's a pity, but it's what happens. Also, there are readability and validity guidance on the standardization bodies themselves, but sometimes results are less readable than others. This is something that should be addressed, not to standardization body themselves. I don't come from a standardization body. I come from Universidad Politécnica de Madrid, but to the people that are involved there. Sometimes it's also necessary to have contents that are quite technical because you want them to be reproducible. And this means that sometimes in the sake of readability, or that readability is sacrificed in the sake of precision. That would be my answer.
Thank you, Yod. In the meantime, we got another question in the chat, so maybe I think you can directly see it from Assam. Check if you can see it, otherwise I will read it.
Yeah, by the way, there was a comment by Muhammad saying that ANSI does not develop standards, it's a accredited standards organization. Yeah, that's right. That's just precisely what I said, that in the US, the case is not the same as in other countries. ANSI is the national standardization body in the US, but it doesn't work as in other countries. The development of standards is something that is addressed in a different way. Question about the privacy challenges the EU is currently facing, especially in relation to large language models. What are the main contemporary challenges in this area, and what issues still need to be addressed or solved? Well, this is the million question. I would say everything. So this is what I just put two slides in the end, but there are lots of touch points between privacy and LLMs, starting from the training of those LLMs. As I said, they amass a massive repository of knowledge. Also, because of the technical fashion of how this repository is created, the training process, it's not something where personal data can be easily deleted or extracted, because there's not a single point. It's not like a record in a database that you can delete and say, I don't want to know anything at all from that person. But it's entangled within the model, and it's not easy to just extract the personal data from there. I mean extirpate the personal data from there. So starting from there, from the training part, taking into account that large language models are amassing huge amounts of data during usage, it makes it difficult to deal with, and also the ecosystem with RIG, with MCP, with agentic different architectures that integrate LLMs, not the LLM such, but integration of LLMs in the ecosystem, which become more and more complex. This is becoming more and more difficult. It's true that there are models, there are large language models that can be run on your own computer. Maybe not on your own computer, or sometimes they do, but I mean, in your organization's computer, not in OpenAI, the company that owns ChatGPT, or in Anthropic's, the company that owns Claude, or in any of these organizations, but in your organization. And this somehow mitigates confidentiality issues, but it's just somehow, and usually those models go at least one generation behind the commercial services that exploit models in their silos, where no one can access and know what's happening there, and also with the risk that they are using more and more personal data. So yeah, this is the question really difficult to deal with.
Thank you.
Thank you.
So there is another comment here from Cyril, always in the chat, about US presence in standardization work at present.
Yeah. I'm not aware about any change. Of course, that political situations always affect the standardization process. As I said, policy at small and at large are reasons to push for or against standards. But to be honest, I'm not aware about any specific detail that I can say this has changed in one standard after the current US administration started having power.
Okay. Then I don't see other comments or questions from the audience. I think we can actually close the webinar even a bit earlier. We scheduled until 4, but it's fine if we finish 15 minutes earlier. Just a reminder that everything will be uploaded on our website in the next few days. Thank you, Bora. Bora wrote the contacts in the chat. If anyone else wants to leave their contacts in the chat, you can do it, so it's easier to connect. Thank you again, Yod. Thank you, Ugo, and thank you all for joining us this afternoon. See you next time, and bye-bye.
Thank you all from the
See you.
invitation.
Bye-bye. Thank you.
See you. Bye.
See you.